Hey there, boys and girls. This is Chili, and I'm back for another programming tutorial. This is lesson 5, if I'm not mistaken. So, we're going to get on with that, but before we do, there's just one little thing I want to talk to you guys about. On my forum, a user posted a question about C++. Basically, they wanted to know what kinds of programs you can make in C++, specifically if you can make 2D or 3D games in C++. And they also wanted to know, is C++ the best language to learn for making video games? Now, I will tell you right now that it is the best language to learn for making video games. And all you have to do is look at the commercial games that are out there, and you will see that they are all coded in C++. And the reason for that is that C++ is one of the most efficient languages to code in for making games or any high-performance applications. High-performance servers or mathematical computation programs, they're all written in C++. And the reason is because C++ is fast and C++ is versatile. It lets you do whatever the hell you want to do. Other programming languages, they tend to restrict you, and they tend to do a lot of ass-wiping and hand-holding for you because they don't want the programmer to shoot themselves in the foot. They kind of treat you like maybe a Down syndrome baby or something. I don't know. Maybe I'm being a little harsh, but basically, a lot of the other programming languages like C# and Java, they're more concerned with stopping the programmer from doing something incredibly stupid, whereas C++ is less concerned about that and more concerned about being lean, mean, and efficient. So with C++, it's a lot easier to do something stupid and create code that is unmanageable, but if you do it correctly, it is the most powerful language for making games. Now, the other question that I mentioned was, what can you make with C++? Of course, you can make 2D and 3D game applications in C++. But you could do that in any language. There isn't any specific languages that only work for 3D or something like that. You can make 3D applications in any language you want. The reason why C++ is better than other languages for doing that is because it's faster and because it lets you access the graphics hardware directly, where in applications like Java, that is not really an option on most platforms like Windows. So, C++ is the best language for making games. I mean, if you are a programmer already, maybe if you know a programming language other than C++, then I'm not sure if learning C++ would be essential. I mean, depending on what kind of game you want to make. If you just want to make a simple roguelike or something, you could make that in any language you want, because roguelikes aren't that they're not very performance heavy usually. So in that case, it's not a big deal. Even what was it? Minecraft, that was written in Java, I believe. So yeah. So anything's possible. But if you're learning a new programming language, if you're learning programming for the first time, and you want to choose the language that is the most useful for making games, then you should choose C++. Other languages are good for making web-based stuff or productivity applications for business. But when it comes to games or other high-performance applications, C++ is the way to go. And one more reason to choose C++ is because those other languages I mentioned, Java and C# and other languages like PHP for server scripting, they are all they all come from C++. C++ is the granddaddy of those languages. They are all modeled after C++. So if you master C++, switching to those other languages will be a breeze. And I am speaking from experience here. I've coded C# applications, just simple applications to do some task that I wanted to do. And it was really easy to just make the transition from C++ to C#. And when I got to university, I found out that all the classes were going to be using Java. And up until then, I had only been coding on my own in C++. So I was like, dick! But then I found that it's not that different, and it was a breeze. I mean, I coasted my way through university in terms of programming courses. So C++ is the pimp daddy of all of those languages, and if you learn it, life will become easier, and the world will be your oyster. And that's all I have to say about C++. C++ for president, yes. What else? Yeah, so thanks for that question, and thanks for posting in the forum. I thank all you guys for subscribing and for voting for my videos. Keep that up, and I will keep providing you with lessons. So now, after my shameless promotion of C++ and myself, let's get on with the programming. Alright, so in the last lesson, we learned the if statement, the if conditional statement. And it was good because it lets us, it gives us the freedom of choice. Freedom! Yeah, Mel Gibson is an anti-Semitic bastard. But, yep, it's all good. It's all good, and the if statement is very nice for us because it lets us create interactive applications, and that's good. That's one step closer to making an actual game. The other thing we learned is we met another object for us to use, and that is the keyboard object, which lets us check what buttons are currently being pressed on the keyboard. And that's good too. So the keyboard object, in coordination with the if function, lets us react to the user's input on the keyboard. So I made a simple line of code that moved the targeting reticle to the right when you press the right button, or left, or I don't know, whatever. I did something, and then I told you guys to do the same for the other direction keys. And this is the result of that. This is what you should have gotten. Let's just take a quick look. This is the application. This is how it should work. I showed it to you at the end of the other video, so I won't show it to you again. But basically, in order to implement that, you just copy this form here, but you have to change the function call for keyboard. So you have to change the button that we are checking, and you have to change the variable, or the coordinate value, the position here. Right? You want a bigger number for going to the right, smaller number for going to the left, and likewise for the y coordinates. So just some number changing and variable changing, not a big deal here. But the other thing I got you guys to do was to change the color of the targeting reticle when we press the spacebar. Now, in order to do that, you had to create a new variable. I created a new variable here called GB, which stands for green blue. I set it to 255. And so then I use that variable in our putPixel call for the green and the blue color components. And what happens is if you don't press the spacebar, GB remains at 255, so we get 255, 255, 255, which is white. But if you press the spacebar, GB gets set to 0, and your color becomes just 255 red and 0 green, 0 blue. And that is how that works. Very simple. I hope you did something similar. You might have used two different variables, one green and one blue, which is fine. Doesn't really matter, but I chose to use one and save the space. And that was the assignment. That was last lesson. Now in this lesson, I think maybe you have an idea, maybe not. Maybe you do have an idea of what's next up for us, our reticle. So what are we going to do next for our reticle? Well, up until now, or at least in the last lesson, we can move it, but it just jumps to the right. And as soon as we let go, it jumps back. So, I mean, we can go here. We can go here. Wait, where's my freaking dick? There it is. We can go here. We can go here. But what if we want to go here? Oh, we can't go there. And that sucks balls. I mean, in a normal game or any kind of application type thing, if you want to move your pointer or your cursor or whatever, you press up, and then the cursor would gradually move up like this, right? It wouldn't just jump and then stay there and then jump back when you release it. It would move up, and when you released it, it would stop. And if you pressed up again, it would move up, and if you pressed right, it would move right, right? That's what we want, but that's not what we got, so we got to change something. Now the problem is we're not, all we're doing is we're setting our X and our Y's to new values when the button is pressed. And so it just jumps to the new value. But that's not what we want to do. We want to increase it by a little bit. We want to take its old value and increase that by a little bit to get to a new value. And then next frame, increase that value by a little bit more and gradually increment in some direction, right? So we want to update and accumulate our X and Y values, and in that manner we can move freely all over the screen. Let me show you what I mean. So I'll go with the right is pressed. If we press right, X equals X plus 1. Now, coming at this from an algebra point of view, this is total bullshit, right? I mean, if you showed this to your math professor, he'd punch you in the face. But in C++, this is perfectly fine, and in fact, this is the normal way to do things. What this is saying is, okay, take the sum of the current value of X and 1, and then take the result of that sum and put it into X. So if X is 5, for example, the sum of 5 and 1 is 6. So that's our result. And then store that result in X. So X changes from 5 to 6. And if X is 6, 6 plus 1 is 7, X changes to 7. And so on. That's what we're doing. Very simple. And if we do that for all of these fine fellows here, here we want to subtract because we're moving to the left. Likewise, if we're moving up, sure. If we're moving up, we want to subtract, and if we're moving down, we want to add. If we do this, then as long as we hold down, for example, the right button, every frame, X will be increased by 1, and the cursor will gradually move to the right. That's what should happen, right? Makes sense? Nothing could ever go wrong here. So let's try it. I'll just hold down the right button. Doesn't seem to be moving. No, it twitched here. It's twitching. But it's not moving. It's not doing what it should move. So before we were moving 100 pixels, now we're only moving 1 pixel to the right. This is not progress, people. You know what this is? Yeah, you guessed it. Michael J. Fox. I'm going to hell for saying that. But it was worth it. Alright, so we have a problem here, and I don't know. I have no idea what's wrong. I tried C++. I tried to make you happy. Oh, you don't know what you're doing to me. Oh!
You are tearing me apart, Lisa!
Yeah, I saw The Room for the first time just this week, so I still haven't gotten that out of my system. Such a good movie. So, but seriously though, guys, what is wrong here? Why is this not working? Can you figure it out? The answer is not here, it's up here. The fact of the matter is that the first thing we do as soon as we get into our compose frame function is we reset our x and y values to 400 and 300. So, I mean, even if we increase them by 1, the next time we enter, they go back to the center. So we can only ever change the position on the screen by 1 in any direction. Never more than that, because we have permanent amnesia here. Every time we enter our function, we have to reset our x and y. And that is the problem. So you might say, well, why don't we just get rid of these statements here, these assignment statements? We don't need them. We'll just we'll just keep x and y as they are, and then they won't change from function call to function call. Well, that sounds like a good idea. Let's give it a shot. What does the compiler say? The compiler says warning. The compiler says, why is this guy using uninitialized variables? And yeah, it's good. It's a good question. Why are we using uninitialized local variables? Or why can't we use them? What's the matter with using an uninitialized variable? What could possibly go wrong? Unhandled exception. That's usually not a good idea. That's bad news bears. So what went wrong here? Well, I'm going to show you a little thing here, a little secret, a little top secret programmer secret. And remember when I talked about this autos thing before? Auto! Yeah. What this thing shows us is it shows us the values in our variables as they're running. For example, GB is equal to 255, which makes sense since that's what we set it to up here. And we weren't pressing the spacebar. Likewise, other variables have these values. And here we have our x and our y. And their values are set to 3,341,236. Yeah, so that might be just a teensy-weensy bit off the boundaries of our screen. And that could go a long way to explaining why we got an unhandled exception. So the moral of this story is, if you just declare a variable and start using it, you're going to get some funky value in there. They start off with just some random value inside of the variable. And unless you set that value yourself, you're screwed. I mean, unless you like a random value in your variable. In which case, go nuts. But for our intents and purposes, this will not do. We have to set... Let me just get out of this debugging mode here. We have to initialize our x and our y. But if we initialize it in the compose frame here, we're gonna get Groundhog Day. We're gonna get amnesia, and every time we're not going to be able to accumulate a value for our position, which will allow us to freely move around the screen. Let me just explain a little bit about variables and these curly braces. Variables have something called a scope. And that is the area in which you can refer to them. That's where they exist. And that area is defined by these curly braces. So if I declare a variable inside of my compose frame function, it only exists within this function. And when this function ends, those variables, they get blown up into oblivion. They get destroyed. And then when we come back in, new variables get created with those names. So, and actually, if I were to create a variable inside this if statement, inside this code block that belongs to the if statement, that variable would only be valid inside the code block. And after I moved out of it, it would be gone. Just a little interesting note. So code blocks, they not only group together lines of code, but they define the scope of the variables which are declared within that code block. So yeah, that's a little interesting trivia about these braces. The moral of the story is that if we want to create a variable that persists over multiple calls of compose frame, a variable that doesn't get destroyed at the end of every function call, we need to declare that variable outside of our compose frame function. That's what I'm trying to get at with you guys, even though it took me like 15 minutes to get there. That's the moral of the story. Now, the question that you might have at this point is, okay, if we're not going to declare the variable inside our function, where are we going to declare it? Now, I want you to take a look at graphics, the graphics object, and the keyboard object. These objects are they are also what you could call a variable, right? Now, we've been using them the whole time here, but we never declared them. We just started using them. And a valid question might be, where the hell did these variables come from? The answer is storks brought them. No, that's not the answer. That's what your parents would tell you. But I'm going to tell you what your parents never could tell you because they were too embarrassed or indifferent. You see, when a mommy object and a daddy object love each other very much, no. These objects were declared inside of our game object. You see, compose frame belongs to our game object. And keyboard and graphics also belong to our game object. And that is why our compose frame function is allowed to access these objects, because it is part of the object which our function belongs to. This might sound confusing to you. So let us take a little trip outside of the game.cpp file. We are going to go up here to the game.h file. Double click it. We're striking out into new territories. Oh, you didn't see that. You did not see that. That was not seen by you. Okay, good. Whew, glad you didn't see that. Yeah. So here we have D3D Graphics GFX, Keyboard Client KBD. This is where our graphics and our keyboard objects are declared. Just like when we declare int x, we have a data type and we have a variable name here. Ah, I did it again. There we go. So, this is where babies come from. Okay? Now stop asking annoying questions and get back to your room. Okay. And these objects, they persist even after our function call has ended. Our compose frame function, even after that call has ended, these objects will still stay alive until the end of our game object, which includes these objects. So what we're going to do is we are going to add two new member variables to our game object. And those would be, of course, x and y. Now, if we add these to the game object, we don't need to declare them in the compose frame function. In fact, we should not declare them there. If you declare them there, things will go bad. So just make sure you delete them from the compose frame, just like I have. Alright, so now we have our x and y, and instead of being declared at the beginning of the function, they are declared in our game object. So, let's try running the program and see what happens. Build. No warnings this time. Unhandled exception. Oh no. Okay. Now if we look at our x and y, now they're set to 0 and 0. That sounds a little better, but it's still not good, because if you remember, our targeting reticle has wings that extend up and left. So if the center of the targeting reticle is at 0, the wings are extending above 0, meaning they're going off the screen, which will cause an exception. Alright, so what are we going to do about this? That's the question. And the answer is, first we're going to stop debugging. And next, see, the thing here is that we are declaring our variables here, but we're not initializing them to any value. So when we declare the variable in an object, but we don't initialize it, it seems to take on a default value of 0, which is no good for us. So we could try to initialize the variable here, x equals 400 or something. But that would be incredibly stupid, because we would just be going back to the situation we had before, wherein the variable is initialized every time we run the compose frame, and we just get deja vu and Alzheimer's and Groundhog Day. And that is crap. So we need a place to initialize the variable where it will be initialized only once when we start our program. And then after that, it'll just be left alone, and the compose frame will be free to update it and move the cursor around the screen. And the place to do that is right here. Here we have another function that belongs to game, and it is called game. So there's a game function called game. Now that's a special name for a function. If you name a member function with the same name as the object, what you're doing is you're creating what we call a constructor. Now a constructor is a special function, and its job is to initialize the variables that are members of that function. So whenever you create a new game object, the first thing that happens is this function is called, and all the members of game are initialized. The graphics member, I want to get rid of that space there, the keyboard member, and now we should initialize the X and the Y members. So as when game gets created, X and Y will be set to 400 and 300, and after that it's all up to our compose frame function as to what their values are updated to. Yeah. So let's give it a shot here. Build a solution. Success. Haven't done anything incredibly stupid yet. Start debugging. Alright, and lo and behold, our cursor is now free to roam in the vast blackness of our screen. Go now, you're free! And so forth. So, Houston, we have success. How sweet it is. Oh, the power, it's intoxicating. It's kind of slow, but still intoxicating nonetheless. Alright. So that is how that works. So we've got this this constructor here, and it's going to initialize our variables, and then we just update those variables depending on what keys are pressed on the keyboard, and then draw our targeting reticle. Sounds simple, and that's because it is simple. And that is today's lesson. That was it. Hope you liked it. Now for your assignment, I've already handled motion in the 4 directions here. So I can't give you that as an assignment. But what I can do is I can give you an assignment. If you noticed, our cursor moves really damn slow. So what I want you to do is I want you to make it so that our cursor moves faster. But that's not all I want you to do. Now if our cursor is moving really fast, it's going to be hard to position our targeting reticle with exact precision, right? So what I want you to do is to make it so that if you push spacebar, the targeting reticule moves very slow, 1 pixel per frame. And if you push no keys, it moves at a medium speed of 3 pixels per frame. And if you push the enter key, it will move at 8 pixels per frame. This is super speed. Look at me, I'm Mr. Speedy. Alright. So, we got 3 speeds: slow, medium, and fast. And that's what I want you to implement for the assignment. Now, we are using space key right now for changing the color. So you're going to have to get rid of that. That feature is no longer supported. Get rid of GB here. No, I hate you, keyboard. Alright, and so now we don't have GB anymore, so you have to change all of these GBs here to 255. Now that sounds like a kind of a pain in the ass. So I'm going to show you a shortcut. Select all this text here, go Control F, and we're going to go Quick Replace. We're going to find GB, and we're going to replace it with 255. Alright, click here to replace all. 26 occurrences replaced. And now you can see all of our GBs have gone back to 255. Alright, build that. Perfect. Alright, so now we have well, why are we going so slow now? Why are you guys going slow? What's going on here? Oh wait, this is okay, right? This is the part before I implemented the speed stuff. That's what you guys have to do, okay? So we've gotten rid of the color change on the cursor, and now it is time for you guys to implement 3 speed. We gotta put a manual transmission on this baby. All right, so do that, and
Anyway, how is your sex life?